Digitization is like a new frontier. Once we have the digital model, we can make a lot of experiments on it, we can make a lot of variations on it, and we can get all the information we need just a few clicks. The coordination between all the different engineers involved in the design is crucial when it comes to digitization. The better this coordination is, the better will be the result on site.
This is the Mass Timber Group Show. I'm Brady, and today I caught up with Franco Piva, the founder and director of Ergodomus Timber Engineering, a firm with over 3 million square foot of timber projects across 300 buildings. Franco worked on his first timber project back in 2003, started Ergodomus in 2007, and now he's working on timber buildings across the globe, including some of the most challenging built environments like Venice. Franco walked us through why digitalization in the timber world is so important and how it de-risks timber buildings for clients, which leads to more mainstream acceptance. We unpack the best practices he follows, common obstacles and their solutions, and where the future of timber engineering is headed. But before we jump in, if you want the skills, knowledge, and tools to confidently work with Mass Timber and win more projects, you need to check out the Mass Timber Group Summit this August in Denver. We've got incredible workshops across the entire design build process, 3 amazing networking parties to connect you with Mass Timber leaders, 6 mastermind sessions to leave no questions unanswered, and building tours of the coolest projects in Denver so you can see in person the benefits of Mass Timber. I guarantee you'll walk away with the information and connections to level up your timber career. Check out the links in the show notes below for more info. And if you like these podcasts, subscribing to the channel is the biggest compliment you can give us. It helps us book incredible guests like Franco and bring more Mass Timber awareness to the rest of the world. So with that, let's get into it.
Digitization is like a new frontier. It is something we need to face when we design. Every time we design, we engineer a new structure in this office, my company, because digitization gives us the possibility to have a digital twin of the timber structure of all the structural elements. Our client will receive on site, like in 3, 4 weeks, 8 weeks, whatever. Uh, Digitization gives us also the possibility to somehow to foresee the problems, to avoid unexpected events on site. And so at the very end of the day, I think that this can be seen as a value engineering tool. Uh, we can really, once we have the digital model, we can make a lot of experiments on it, we can make a lot of variations on it, and we can get all the information we need just a few clicks. It is quite complicated to get there for sure. But once you have the 3D model, everything gets much, much easier than in a non-digitized world.
Got it. What are some of the common problems that you see specifically in timber buildings that happen when they're not designing in a digital 3D environment?
The biggest problem is that you receive something on site and you have to change it to add some holes to make the beam, for instance, 2 millimeters shorter because during the engineering process, you didn't have the time or you did not consider the tolerances. So this is the biggest problem. And in some cases, in many cases, this is caused by the lack of information we received during the engineering process. The coordination between among the different engineering teams, among architects, mechanicals, steel, concrete engineers, all the different engineers involved in the design is crucial when it comes to digitization. The better this coordination is, the better will be the result on site.
Hey, we're going to get back to the podcast in just a second. But first, I have a question for you. Are you somebody looking to build a mass timber project? If the answer is yes, then you need to put together an experienced team.
Our partners at Cornerstone Timber Frames are leaders in heavy timber construction and have 30 plus years of experience, which means you can trust them to get the job done right.
They collaborate with Nordic Structures to bring you the highest quality FSC certified mass timber available. They also have some of the most advanced fabrication technology in the industry, so your project goes up smoothly without costly on site modification or delays.
That means they have the experience, network, and technology to make your next mass timber project a success. Learn more about Cornerstone Timber Frames by clicking the link in the show notes below.
Got it. And you did a post on LinkedIn maybe about a week ago talking about the different LODs that engineers and stuff need to get to in order to like make sure that mass timber is effective, cost effectively, structurally, et cetera, moving forward. Like, is there a certain time frame or LOD level that you'd like to be working with the entire design team on at like a certain stage in the process?
I think that the most important stage is ironically the most underestimated one. We, the LOD 100, which is the schematic design, is super important, and it is where timber engineers should be involved in the project at the very early stage when architects and other designers and even the clients are on the same around the same table talking about the needs, talking about how the building could look like. So at that stage, LOD 100 is where you have, you can say, more power to change the project, more power to suggest changes into in the project. Uh, it is a stage where you almost should not use the computer because it should be just sharing sketches, hand sketches, or sharing a screen. What about having this solution? What about moving that column? What about adding a couple of columns there and removing other columns on the other side of the building? So this is a very important stage. Then of course we need to move from 100 to LOD 400, which is the highest one, at least the highest one for us, which means up to the CNC files, up to the production files. If you try to work on LOD 400 without having say a good LOD 100, then it's going to be a very painful stage, the last one.
Is when you let's say that you get to LOD 400 and you didn't do the pre-work like you talked about at the 100 level stage, does that add a bunch of cost for the end consumer if you're trying to jump in at that level?
This is a big risk, a big and real risk, because if someone else moved from LOD 100 to 300 without having in mind logistic, without having in mind the connections, without having in mind what the manufacturers can make and what they cannot make, then our our job will be to make this project possible. So in some cases, it can happen that we need to increase the depth of the beam or to change the material to move from uh, a lower grade of material to a higher grade of glulam, or to move from a 5-ply to 7-ply CLT because we noticed that there are some other problems. So the answer is yes, we can have some extra costs for the client. That's why I like to say that using digitization, we can also reduce the risk. We can de-risk the project for the client. We can basically foresee all the different aspects, even the most hidden one, and avoid unexpected new costs for the client. So the client will not be like, oh, I was not, I did not consider these 100,000 euros more. So yeah, we need the risk of having extra cost is real if we are not involved in the early stage.
Got it. And how many of the projects that you're working on are not at the time that you come in are not using these digital tools and building these twins in the 3D environment? Like, how would you say that split is?
I cannot say a real number, but I would say is more than 50%.
Why do you think that is?
I think there is a quite big lack of education in general among the designers. I don't want to say that they are not good. They don't know how to do their job. They are great in designing amazing buildings. When it comes uh, to move from a schematic design or even a detailed design to the production drawings, then there are so many details that you cannot see in the previous stages that the designers are not ready for that, are not enough educated to work at this level. They are very familiar with concrete, they are very familiar with steel, but they are still not very familiar very familiar with timber. With timber, you're gonna have bigger elements in many cases. You should, in some cases, you have to increase the size of the elements just because you do not have enough room for the dowels, for the nails, or for the connectors. So with steel and with concrete, this problem is they can consider this at the early stage. And with timber, sometimes they are very surprised. Oh, wow, these elements are too big. Let's try to find a different solution. But we are already somewhere in between 300 and 400, and this takes time. So it is. I, I, I really like that the industry in general, especially the automotive industry, uses the McLeamy diagram to move the efforts of in the design at the very early stage, so that they reduce the effort once the times goes on. I really would like we could do the same, a similar thing also in the building industry. This could be beneficial for all of us.
Got it. Got it. And you talked about the familiarity with design teams in concrete and steel structures because you've been designing with them forever. Do you think that there is a difference between an engineer firm that's been doing concrete and steel for a long time and they're getting into timber versus like a very specified timber engineer, if you will, when you're designing these buildings? Like, what are the different skill sets or gaps that you see between the two different focuses?
Yeah. So the answer is definitely yes. There are many differences between steel and concrete engineering team and the timber engineering team. I think one of the biggest difference, or probably the biggest difference, is how to manage the connections. Steel engineers have already the mindset that they have dowels, they have bolts, well, bolts. um, uh, they know that they need some room to create this connection, but at the same time, they have always sort of a plan B. They can weld the two elements together. In timber, we cannot weld to glue the elements. It is doable, but there are some limitations given especially by the environment, temperature, moisture content. You need to control these parameters for hours, maybe for 24, 30 hours. So the connection design is really the biggest difference. And at the second position, I would say that is the behavior of the material. Timber is like it's like working with a material which is alive. It moves, it changes slightly its size continuously, 24/7, because of the moisture, especially. So you need to consider all those things when it comes to the design. And steel and concrete guys are not always aware of the real behavior of timber. And I must say, I only design timber. So if I had to design a concrete structure, I must admit that it is not my job. I would ask another engineering firm, can you help me to do this? And the same thing for steel. We design something very small in steel. If provided it is part of a timber building, especially in this period, have to be the you have to be super skilled in timber, concrete, or steel, or other materials.
So, as mass timber grows in Europe, but especially here in North America, Do you see like a specialized timber engineer trend start to emerge out of this, or do you think it's going to be concrete and steel guys working on timber buildings, or are there going to be more like timber specialized engineering firms out there?
So to educate new engineers, new generations of engineers, to teach them how to design timber, how to correctly design timber, it takes a while. It takes a few years. So I think that in the next 4, 5, 6 years, it will be more engineering, the steel and concrete engineers moving to working on timber, moving to another area, which is good because I'm a big fan of hybrid buildings. I think the future will be to design buildings, getting the most out of each material. So I'm definitely a guy saying yes, let's go for a hybrid. But at the same time, I think we really need to have those that new generation of timber engineers, and it will take a while. So we need to, in the meantime, we need to create like a bridge between now and the day we will have these new engineers. Here in Europe, the 2 countries, 3 countries where you can find very good universities to train new timber engineers are Germany, Austria, and especially Swiss. Here in Italy,
And
not that.
before we started recording, you talked about the infrastructure investment in the mass timber world out in Europe, like new plants, new machinery, increased supply capacity. And then here in the States, we're seeing the same thing. And then our growth trajectory, depending on who you talk to or what data sources is like, it could be anywhere from 25 to 40% year over year demand for mass timber buildings. Do you see that there is any sort of like risk in that quote unquote explosion of mass timber adoptions and then the gaps between the knowledge base, whether that's codes or designers? Like, where do you see that gap playing out and then tying that into the bridge that you just talked about?
Yeah, there is a gap because for the industry, it is much easier for them to build a new factory than build a new generation of timber engineers.
Yep.
So for them, once they decide to invest 80, 100 US dollar million to build a new factory, 3, 4 years, and the factory can be up and running more or less. If they are very efficient, this could be the right time. But then having the CNC machines, having even the best presses on the market, the best layout on the market, it is like having nothing if you do not have the right people to feed the production, to prepare the to correctly prepare the files for the production. So I think that the risk is real. Also, this is a risk we need to consider, and I really hope that all the timber industry will try to invest as much as possible in education. One very big difference I see between Europe and North America is that in North America you started like more or less 15, 20 years, well, 15 years after Europe adopting mass timber for large scale buildings using CLT, but you are running much faster, and this is good. You are producing a lot of documents, a lot of manuals, a lot of handbooks. Uh, if you try to Google for CLT manual, CLT examples, CLT handbooks, you find a lot of information. While if you do the same in trying to limit only Europe, you do not find so many resources. So I like what Woodworks, FTI, and other organizations are doing at the moment, and they are. I'm sorry to say that, but they are doing something better than us at the moment. Yeah, I, mean,
Uh,
I would love to say something different, but at the moment, between European countries, is not so. We're not working so much together to produce those documents.
And so timber engineering, as we're talking about it, has been around in Europe for far longer than it has over here. I mean, especially in like the CLT space. How did the industry in Europe go for 2 decades longer than North America without kind of that database and resources? Like, how are the timber engineers in your part of the world going out and finding the information that they need? Like, we have organizations like Woodworks and you named a couple others here where we can just point our design and engineering teams to those resources and they can learn. Like, what does that look like in your neck of the woods?
Well, I started in 2003, September 2003, so it is like a bit more than 20 years ago. And at that time, there were just two manufacturers all over the world of CLT. And I remember in the company where I was working, we were, I could say, constantly in contact with them because we were one of the very few companies using CLT here in Italy. So they were teaching us based on the university research, based on their experience. The production, you have to consider that the production was about the global capacity model, not the production, but the global capacity at that time was 40, 50,000 cubic meter per year. So even for them, we were like, we were all pioneers in that period, and we were trying to share as much as possible our knowledge to get information and to give them information. So I must say that it was not so easy as it is now to design a CLT building. Uh, Almost no standard connections. We had to create a lot of times, we had to create our own connections, and it takes a lot of time. So I like when now I can just Google for something either in English or in German, and I can find the information I'm looking for. I cannot say always, but almost. At that
Got it.
time, it was a hard time, Brave. Trust me. Yeah,
So you had to basically go directly to the manufacturers and universities
right.
and just
Yeah,
work hand in hand and then share lessons learned and build from experience and one-on-one conversations
yeah.
rather than like a centralized database like we can find today.
Experience was much, much more important than now. The
Got it.
experience of my colleagues, of all the carpenters, was very important to show me, to tell me the behavior of timber. Pay attention to this detail because we could have water, we could have problems with moisture, we could have expansion. At, at that time, it was very very important to learn from their experience, and still
So
now it is very important.
absolutely. And you brought up water and moisture. And I know that seems to be like a very big sticking point for at least end consumers, developer owners, when they're considering timber buildings. It's like, hey, how do you deal with water and moisture, external and internal? Like what's been your experience? Like, how are you guys tackling that objection to timber buildings?
Yeah, in my experience, we we always need to consider the water. There are many clients or players involved in the design that are worried about fire, worried about earthquake. It is very important, and they are right for sure. But water is something you do not see. Many
Yes.
cases, you have just some drops of water coming from outside, or maybe even from inside. We are working on to solve some problems on a couple of buildings where the water comes from inside because there is a very, very, very little leakage on a pipe, and you do not see it, you do not hear it. So you realize that there is something wrong after months. So in that case, I always suggest to my clients to adopt strategies to monitor the moisture content 24/7. To There are many products now on the market, fortunately, so you can just choose the one you like, the one you are happy with, and in case of problems, you receive an alert, you receive an email, or there is an app on your smartphone telling you, look, there is a problem in that sensor, which is in that position in the kitchen or in the bathroom or in the green roof. So you can immediately realize that there is something not good. Timber is a beautiful material. I even like to create my own furniture at home because I have a small workshop. But at the same time, we need to know that water and timber are not good friends.
Yeah.
If there is oxygen at the same time, is a it can be a very bad combo. Water, oxygen, and timber. It's the perfect environment for fungus, for uh, mold, etc. And they can eat timber. So I hope we will continue. The market will grow and grow and grow. This is my dream. This is what I'm aiming to. But we need to pay attention to earthquake, fire, absolutely. But the water management, I think it is the most important part we should consider.
Yeah, and so on the prevention side, right, you talked about installing sensors, right? So you can catch those problems early if they do occur. And we all know that there's, membranes that you can apply to help shed water on the exterior, maybe in your wet room, stuff like that. What about on the back side for water and fire after something bad has happened? That's been a big question. I'm talking to a lot of developers, specifically out in Colorado right now, and some of their big concerns is like, okay, well, let's say you do have a leak and it does cause a bunch of mold and rot and stuff like that, or a fire, right? Or earthquakes, we've kind of settled that with a lot of the NERI data coming out that timber is very resilient in a seismic
Yeah.
event. But let's say that a fire or an internal flood goes through a building. What are you seeing as far as like how do we repair and mitigate these buildings? And is it a deterrent to developers to use timber? Is it too complicated to repair these buildings, or what's your opinion?
Well, I cannot say that it is too complicated. It is complicated. It is something we cannot ignore. We cannot. Sorry, it is not something we cannot make it. But it is very hard to work on those buildings in case we have problems, because the only way you can do is to remove the rotten part, which is basically without any mechanical properties. It is really like something you can break by hand. It is really soft. You can break it. So you need to remove that rotten part, and you need to glue new elements or to add or to add a part of the beamer or a part of the column. So it is like the process is like remove what doesn't work anymore and add new materials. The bigger the building, the bigger the problems in case you have leakages of water. So the reason I'm saying that we must have a monitoring system, a system that works, that monitors 24/7 the building, is that we need to prevent the problems, and in case of problems, we need to see immediately that there is something wrong. 1, 2 months is not a problem. Having water for 1, 2, 3 months, 1 year of small leakages can be a big problem.
Yeah,
So we need re- to have an alarm telling us, "Hey, there is a problem here."
got it. And so we talked a lot about fire, water, seismic stuff. Those are kind of like big headline objections, if you will, or concerns with timber buildings. Uh, but we've seen these buildings go up in like incredibly challenging built environments. Like I know that you've worked a lot in Venice. Can you
Yeah,
talk about kind of like some of the big challenges and lessons learned you've come away with like working in an environment like Venice?
yeah. I must say that I'm a bit laughing because Venice is for sure it is the strangest city I've ever seen. It is like 2 hours, just 2 hours drive from my home, so I can go there very easily. Uh, in 2016, we worked on a project there for the very first time, and we were on the island. And I realized in that on that project that Venice forces you to think about everything. It's like I like to say that it is like working on the moon. You forget something. You forget very simple. You forget one box of screws, of timber screws. You cannot take the car or your truck and go to the first shop. You drive 20 kilometers. You go to the shop. You take the box and you go back. No, it is not like that. You need to take the boat. Takes a lot of time. You go to the mainland, and then on the mainland you have to go to the parking area where your car is. You need to find a shop, go there, take the box, go back. In many cases, you have to consider the tide because if it is too high, you can't go with your material below the bridges. So you have to think about that element will be like 2 meters high. So this is the path to go from that point to the other point. We can do that thing only between 3 a.m. and 5 a.m. You have to find a company that makes this thing for you, or they tell you, no, we make tomorrow evening because there will be again a low tide. Uh, It is so complicated because if you go there as a tourist, you just see the beauty of the city, and you love it. I love that city, and now I love it more because I see what is behind, what living there means. Working there, it is really something.
It's like
We learned
it
a lot.
it takes, what people would consider, like, site logistic challenges in an urban infill to a whole whole 'nother level when you have to deal with water
Yeah,
and tides, 2-hour, install, drop off delivery windows, like, that's pretty
yeah,
tight.
yeah, yeah, yeah.
Yeah.
So every second year, there is the Biennale of Architecture or the Biennale of Art 1 year after, and it is beautiful to go there and visit it's not a conference, there's a exhibition, but it's not open for public. But the most beautiful part for me is to work there for 6 weeks before the vernissage, before they open, because you see literally hundreds of people working there 16, 20, 24 hours per day to complete the pavilions, special transports, materials arriving from everywhere, from all over the world. That is the most exciting part of the projects. Once, 4 years ago, 3, 4 years ago, we worked on a pavilion inside a uh, inside a church, inside a building, an old building. And we completed the pavilion at 4 a.m. and the opening was at 9 a.m. So we worked literally for 48 hours well, more, it was not just me for sure, but the team worked for about 48 hours to complete everything. And we completed around 3 a.m. or 4 a.m. And at 9 a.m. there was a big opening, and our pavilion was the first one. So we could not uh, leave it there not completed because all the presidents, directors, etc. The opening was there. It was a big adventure.
So
I still have good memories about that.
so it sounds like you've had a lot of fun doing work in Venice. Has there been any
Yeah.
project is there, like, one project that really, like, stands out to you that you're very, very, you either learned a lot from or you're very proud of in this timber space across the world in Venice or otherwise?
Oh, I cannot say that there is one single project. There are so many projects I enjoyed working on. The ones in Venice. Uh, we worked on a few projects in Scandinavia, in North America, and Australia. We are working on a project now in South Africa. Every project has something special. Maybe because of the logistic, maybe because of the shape of the building, maybe because of the challenges, because of the needs of the clients. I I cannot say that project or those two projects. No, it is something I can't make it.
Yeah, fair enough. It's like trying to pick your favorite kid, right?
Yeah. Yeah, yeah,
Yeah,
correct. Yeah, yeah, yeah.
yeah,
You cannot say you
yeah,
the first one, the second one.
yeah, exactly.
They are
So
all good.
you talked about, so I know, and I'll point the audience to your website so they can see, but you've got a map of all your projects, and you guys are building all over the Eastern Hemisphere. But now you're also making a push into North America. Like, what are the differences between timber engineering in the eastern part of the world versus the West, what I'll call North America?
I think the modern modern timber engineers, I would say that the market is very different. In Europe, we started from zero, let's say, many years ago, and we moved very slowly from one single story building to multi-story building. While in North America, especially, they started very soon with large scale building. Uh, they proved that timber is a very good material to go for. Here in, especially in Italy, we're still in a stage talking about one single family building, one story building, or with small scale buildings, uh, because there are many reasons behind that, but this is the biggest difference I see between North American continent and European continent. Talking about timber engineers or in general engineers, I cannot say really the difference between the two. Of course, there are different backgrounds, different educations. I I cannot say really this is the difference. I don't know.
So but it sounds like it's kind of the building scale, if you will, so a lot more smaller
Yeah.
buildings in Europe, and then
Yes.
over
Yes.
here, I mean, we're starting to work into smaller buildings, but we, like, you're right, we started off with the huge ones, right? You know, they're
Yes.
doing million square foot buildings on some of these big Google, YouTube type style structures.
Correct. Yeah.
Um, what what advice would you give to maybe a young a young engineer that's working into timber? Because like you said, the industry in North America is very much younger than it is in Europe, even though we're working at different scales predominantly. But like, what advice would you give to people who are exploring timber engineering as a career?
I think well, first one they have to choose the university where they teach where there are courses about timber, and I'm sure that there are a few universities west on the west coast or on the east coast, and then I suggest them to go to try to work in 2, 3 different companies to understand what timber is, to see different uh, philosophies, different approaches to the design. What I really suggest them is, even if they think to be structural engineers, I I hope they will have the opportunity to work on a digital model, to create a 3D model, because then you perfectly understand what a connection is, uh, where the dowels are. You get familiar with the CNC machine. You get familiar with the production side. So what I suggest them is try to work in a company where they produce CLT or GLT. To see only the engineering side is not good enough when it comes to timber. You need to learn how the production is. You need to learn. I say that there is like a black box between the architectural drawings and a CLT panel on site. You must know what this black box is.
Got it. Got it. And so pushing, you mentioned a lot digital twins, 3D design environments. Like, is that a big focus of yours moving forward, is trying to push the industry in that direction? Or what's your big goals right now?
Um, I really would like to show people what this black box is. Sometimes I think that this is like a Pandora's box. You open it, and once you try to dig a bit and to see what's inside this box, there is like a new world. You are disoriented at the beginning. You get a bit you feel like a bit lost because you need to consider production limits, logistic, CNC files. You draw something, but then there is the obstacle. The CNC machine cannot make it. So you need to redesign the details to consider that instead of having a 90 degrees angle, you will have a round angle. And this could be something not important, or could be something very, very important, so that on site they have to use the chainsaw or another tool to make 90 degrees. And this takes a lot of time, Brady. Really is this process takes a lot of time. And in many cases, my frustration as timber engineer is that they say, "Oh, it is just a copy and paste. It's just a few lines on the 3D CAD software." No, it is not. It is not. Digital model can make you invest more time. You pay more money in in this part or in this stage of the project, and then you save time on site. I've been trying to convince people, developers, builders, etc., designers and other designers. I've been trying to convince them to show them this for a while, and maybe slowly we're getting there, but it takes a while still.
Got it. Got it. Yeah. Well, I think you've explained the benefits of working with that philosophy quite thoroughly. And so hopefully people are listening to this, take note, move forward and kind of pursue those tools that are available because it's going to save everybody a lot of headache cost moving forward. And it's just going to push timber engineering and timber buildings um, into the mainstream even more if it becomes easier. And as you said, de-risks that process. Um,
Yeah,
what,
yeah,
yeah. So after all of our conversation, like you're obviously incredibly knowledgeable. Like you said, I think you said designed your first timber building in like 2003. Did you say?
yep, correct. Yes,
Yeah. So call it 20 plus years now. You've been
yep.
learning direct practitioners, talking to manufacturers, working with universities hand in hand. Where else do you go for information? Do you read certain books, podcasts? Do you go to conferences? Like, where do you go to learn about timber engineering?
Well, yeah, you mentioned podcasts, conferences. I'm happy we met in person in Portland just a few weeks ago. There are many now resources where you can find information. Conferences, I think, are the most important ones at the moment. You go there and you you can find you can listen to people present talking about their experience. So it is very, very important to go to the conferences, in my opinion, also for networking, but not only for networking. And as I said, I strongly believe that sharing the knowledge is very important. And please allow me to say that we are small company, but we are trying to do this as well. So every year in May, in the month of May, we organize a virtual conference. It is just an online conference, and playing with the words, we call it DF May, which is a mix between DFMA and May. Every year, we invite 4 or 5 speakers sharing their experience and how they use the DFMA approach to design their building, what a price. This year, I asked them to share some problems they had on site to say, we had this problem and we solved it. It was very painful. We had to realize that we were not going in the right direction. So it would be a very, uh, I, I'm sure it will be a very interesting conference this year, and it will happen on May 29th. It is a free conference. I strongly believe that a certain level of knowledge must be available for free on internet. Because if we think that everything must be paid by, I think, for instance, a young student. I hope they can go, and now it is quite easy for them. They can go on Google, they can find some information, and also with, um, yeah, very easily they can find this information, and DFMA will be available right after the conference. It will be available for free on YouTube. Edition 2023 and edition 2022, they are they are available anytime. There will be a round table, a Q&A time. So if they have question, will be all the speakers will be there and happy to reply.
Yeah, I'm really excited that you guys are doing that. We're also big believers in the more education you can get out to people, the better. Like if you're going to get around people at conferences, virtual or in person, that's where you're going to build the relationships. That's where you're going to build the connections to go out and get answers to your problems, solutions to those problems, and then take those lessons into your practice. And the more information, especially like you talked about that gap between where the industry is capable of and like the skilled people that are coming in to fill those positions. Like if you're not providing the education to that next generation of timber engineers and designers, it's going to be hard to fill that gap that we talked about before. And so
Yep.
the democratization or the free availability of these information sessions are so critical, especially when they're coming from real world practitioners like yourself and the other people you're going to have at your conference to say, here's what we learned. Here you go, next generation. Don't make the same mistakes that we made. And the more you can reduce that barrier, I think it's going to create a tide that lifts all boats in the mass timber industry. So thank you for doing that because we know that conferences are a big lift, virtual or otherwise. So to do this, it's a big undertaking, and especially to do it for free, like kudos to you. That's really cool.
Well, you're doing something very similar in a bigger scale. I mean, Brady, you are having these interviews. You are promoting the mass timber. You're doing great on this channel. We met through LinkedIn, which is the main platform I've been using for years to get in contact with people from all over the world. And I think the very first one is a friend of mine from Australia, Paul Kramer. He created the Mass Timber Journal, I don't know, maybe 6, 7 years ago. And he was the very first one promoting mass timber, sharing posts about projects. And thanks to him, I'm sure that many people at least had a thought, oh, I could go for mass timber for this project.
Yeah. Yeah.
So I hope this, what we are doing right now together and what you've been doing for a few years, for a few months, uh, this will, I hope that this will bring to um, having people thinking, like, yes, try to go for mass timber for this project, or at least they think about it.
Yeah. No, I fully agree. Last question, where can people get in contact with you?
Well, the main channel, the main media we are using is is LinkedIn. They can follow our company page, Ergodomus Timber Engineering, or they can contact me. I guarantee that it will be me replying the messages. It's like a second job. Uh, Sometimes it takes a they have to wait a few days, uh, but the good side of LinkedIn is that you can really get in contact with that guy, and so they can contact us or through LinkedIn or through the website. There's also on the website there is a quicker maybe, but both channels are okay.
Okay. And so I'll link your LinkedIn, the company's LinkedIn, your website, and then information on the conference down below in the show notes for anybody that's interested in connecting with Franco or attending that free online conference. Um, I had a blast today, Franco. Thank you so much for
Well,
staying at the end of your workday to come talk timber nerd stuff with me. And I wish you the best moving forward. I'm excited to see your conference online. I will certainly be listening to those seminars.
Well, thank you very much, Brady. So I'm very happy you decided to interview me and to give me this opportunity to share my knowledge. Very, very
Yeah.
happy and congratulations for what you've been doing, guys.